Okay, this is the P3 paper from June 2022. If we take a look at it, we can see quite clearly this is a trig functions question. It's going to be involving cot, sec, and cosec. If we look a little bit further down, we can see we've got a trig equation to solve. And in order to get this first part, we're going to need to do trig identities. So let's make a start. 2 sine theta 3 cot squared 2 theta, okay, minus 7 is equal to 13 sec theta. What are we trying to make it look like? 3 cosec squared theta minus 13 cosec 2 theta minus 10 equals 0. So my students will often say, "Sir, I don't know how you work out where to get started." And my reply would always be to them, well, I know all the identities really, really well. And if you don't know them really, really well, you are going to struggle to do this one. So things like sine squared plus cos squared equals 1, or tan equals sine over cos, you must just know those and know them and manipulations of them. So sine squared plus cos squared equals 1, you also need to know sine squared is 1 minus cos squared, and maybe even sine is the square root of 1 minus cos squared. When it gets to the ones that aren't quite so well used, what I would expect you to do is have an understanding of the relationships between them. So I know, for example, that cot squared and cosec squared are connected to each other. I might need to look in the formula booklet to find out how they're connected, and I know it's either 1 plus cot squared is cosec squared or 1 plus cosec squared is cot squared. I haven't learnt that as well as I can do, but certainly I know that cot squared and cosec squared would be connected. Just that piece of information then absolutely helps me to get started with this question, because if I'm looking at this bit in here, I don't really want to play around with that too much then, because I know that 3 cot squared 2 theta minus 7 I can change to cosec squared 2 theta, and cosec squared 2 theta is in the answer there. So that sort of gives me my clue as to how to get started with this then. I don't want to mess around with the 3 cot squared 2 theta minus 7, which means I don't want to multiply it by sine, otherwise that's going to change it. So what that tells me to do then as my first step is to do that. Take the 2 sine over to the other side and divide it out. If I've got that now, as I say, I'm now going to leave 3 cot squared 2 theta, 3 cot squared. Just be careful when you're doing all your copying down as well, you don't make any errors like that. But what's 13 sec over 2 sine? Well, sec is 1 over cos, and again, you should know that. So now I've got 13 over 2 sine theta cos theta, and straight away, when I'm looking at it, that one there just jumps out at me because I know that that's sine 2 theta. So, as I said to you at the start of this question, knowing what your identities are really is absolutely essential to this, because I've now got 13 over sine 2 theta here, and I know that 1 over sine is cosec. So right, I'm getting really close to my answer now, because on this side I've got 13 cosec 2 theta. Now you could have changed this 3 cot squared 2 theta minus 7 right at the start. You could have done all that. I was just, because I'm explaining it to you guys, I'm just focusing on the right hand side. But at any stage you could have said, hang on, what's the connection between cot squared and cosec squared? And that's the connection there. Okay, well that means then that cot squared is cosec squared minus 1. So I can put that in here to be able to tidy that up to work out that bit. So as I say, you could have done that right at the start. I just wanted to focus on one side as I was going through. And I may well do that in the actual exam as well. If I was doing this during class time, no, I probably just would do it all in one go. But when I'm in the exam and I'm a bit nervous and I'm trying to make sure that I don't make any mistakes so that I need to go back and check them later, then it's not bad thought process to go through. Right, we're nearly there. We've just got to multiply this all out, and hopefully I'm going to end up with what I was trying to prove. So I'm trying to talk and write at the same time, which is never a good idea in me. But so we get that, make it all equal to 0. But I'd say we know what we're looking to try and get to. And there I've made a mistake. Just with that bit there, this should be 2 theta, shouldn't it? Whoops. That should be a 2 theta there. Just check I haven't done that anywhere else as we're going through it. No, it all looks okay so far. I don't necessarily take a mark off for that, but just be careful anyway. So we've got 3 cosec squared 2 theta minus the 13 cosec 2 theta minus 10 equals 0. Fingers crossed. When we go back, that's what I was trying to get up there. So that's part A done. Part B then says, can we solve this? And always check here and here. I want to solve this from 0 to 90 or 0 to pi over 2. And I want to give my answers, it's going to be in radians because it's pi over 2. And it's to 3 significant figures. As soon as I read that bit there, I'm changing my calculator into radians mode. Just be careful when we're going through and doing these. So if I'm going to solve the original equation, I can use the equation that we've just, for goodness sake, the equation that we've just made. 3 cosec squared 2 theta minus 13 cosec 2 theta minus 10 equals 0. I'd be very surprised if this quadratic doesn't factorize, so I'm definitely going to have a go at doing it. If you're unable to do these sorts of factorizing, go back and look at somewhere else on my channel. I'll have a how-to video on this, but you've got to be good at factorizing quadratics. It's really, really important. I'm not spending any time here going through it. It factorizes to 3 cosec plus 2 and cosec 2 theta minus 5. Whoops. Equals 0, which is going to give me my 2 possibilities. 3 cosec 2 theta plus 2 equals 0, or cosec 2 theta minus 5 equals 0, which is going to give me cosec 2 theta equals minus 2/3, or cosec 2 theta equals 5. We remember that cosec is 1 over sine. So sine 2 theta is 1 over minus 2/3, which I'm hoping at exam level you should just be able to do that straight away. And here we're going to get sine 2 theta is equal to 1/5. And guys, you need to practice these questions. This does not surprise me at all. And in fact, I was hoping to have this situation here where I don't want to repeat the same method all the way through. So quite often it could have been sine 2 theta equals 0, 1 or minus 1, because if I'm trying to solve those, then I tend to use the curve to be able to work out the values for 1 or minus 1 or the noughts. So that's a slightly different version to actually, if I'm doing sine 2 theta equals 1/5, I use the cast diagram to be able to solve that one. Again, go back and have a look at my previous channel entries to work out how to finish off this one. I'm not spending any time on this, otherwise my videos will all be 2 hours long. If sine 2 theta equals 1/5, 2 theta works out to be either 0.201 or pi take away that is 2.94, remembering they're in radians, and then theta works out to be half of that, obviously 0.101 or 1.47, both taken to 3 significant figures, and then go back and just check that. But yeah, absolutely, I haven't made any mistakes with that. So hopefully that all makes sense for question number 7.